Okay, welcome back. This is Notes 2.4. And on this, we're going to be talking about percent composition and empirical formulas. This is going to be in your textbook, pages 348 to 355, and then in your study guide, 128 through 152. All right, so first, percent composition. So go ahead and write this down. All right, molar mass. Molar mass or molecular mass is used to calculate the percent composition of each element in a compound. All right, and what I want you to remember that a percent is a part of a whole. Okay, so if we were going to look at the percent composition of, say, water, there's two elements here. So percent composition is what percent of this total mass is contributed by the hydrogens, and what percent of the total mass is contributed by the oxygen. So what part of this whole thing is the hydrogen, and what part of this whole thing is going to be the oxygen? Okay, so that's what percent composition is. All right, so what is the percent composition of calcium chloride? So write down these three steps. All right, so the first step is to calculate the molar mass. The second step is to divide the total mass of each element by the molar mass, and then multiply that by 100 to change it to a percent. All right, so the first thing we want to do is calculate the molar masses, and this is from your last video. So calcium, there's only one calcium here, okay? And then the chlorine, there's two, so two chlorines. All right, so let's use the molar masses from the periodic table that I gave you at the beginning of the year that you wrote down, that you glued in your book. So calcium is 40.08. If you use other molar masses, then that is going to give you a little bit different numbers. So you're going to get different answers. And then if you use that same one on your problems, you're going to get maybe a little different answer than me. So let's all be consistent and use the periodic table that we glued in our notebooks. All right, so calcium is 40.08 grams per mole. Chlorine is 35.45 grams per mole. All right, so let's multiply those out. So 1 times 40.08 is 40.08, okay, grams per mole. And then 2 times 35.45, it's going to be 70.90 grams per mole. All right, so we add those up. Okay, and that gives us 110.98 grams per mole. All right, so that's our total. This is our whole. That's our total. So to find the percent composition for calcium, we're going to take our part, which is 40.08, divided by the whole, which is 110.98. And we're going to multiply that by 100 to get a percent. All right, so the same thing for the chlorine. The chlorine is the part is 70.90 divided by the whole, 110.98 times 100, and that'll give us the percentage for the chlorine. All right. So pick up your calculators and do this math. 40.08 divided by 110.98 times 100. Okay. And 4 significant digits. So we're going to get on this one 3.611. percent. Okay, and then calculate the other one. 70.90 divided by 110.98. And then multiply that by 100. We're going to get 63.89%. All right. Now, do you want to check your work? I'm sorry. I told you, my calculator gives me answers in scientific notation. So this is 36.11%. I didn't see the moving the decimal. Okay, so if you want to check your work, you just add these two together. So 36.11 plus 63.89, and you should get 100 or really, really close. And on this, we get exactly 100. Okay, so we have two different elements that are supposed to make up 100% of this. So that's how we can add them together. So that's why I went back and paused, because in my head, I was looking at 63.89 plus 3.6. And I was like, well, that doesn't add up to 100. So I went back and checked my work. That's how I knew that that one was wrong and that it was really 36.11. All right. So you should add both of those percentages when you get your answer, or maybe there's 3 or 4 percentages. You should add all those up and it should be 100. All right. And that's what's called percent composition. So 36% of the mass of this molecule comes from calcium, and 63.89% of the mass of this molecule comes from the chlorine. Okay, so let's do another example. What is the percent composition of C2H6O? Okay, so first we have to do molar mass. So we have carbon, hydrogen, and oxygen. We have 2 carbons, 6 hydrogen, and 1 oxygen. So we're going to have to multiply those by the molar mass of each one. So carbon is 12.01 grams per mole. Hydrogen is 1.01 grams per mole. And I'm getting these from the periodic table. And oxygen is 16.00 grams per mole. Okay, so 2 times 12.01 is 24.02. That's grams per mole. Okay, 6.06 grams per mole. And 16.00 grams per mole. Now we're going to add all those up. We're going to get 46.08 grams per mole is the total molar mass. All right, so now remember, for carbon, we're going to take the part divided by the whole. Okay, for hydrogen, we're going to take the part divided by the whole. And for oxygen, we're going to take the part divided by the whole. And we're going to multiply each one of these by 100 to get them into a percent. And that's going to be our percent composition. So 24.02 divided by 46.08 times 100. Okay, 52.13. Okay, and then 6.06 divided by 46.08. Okay, and that's going to be 13.15. All right, and then 16 divided by 46.08 times 100, 34.72. That's a wonky looking 4. Okay. All right. Now we should be able to check our work by adding these, and they should equal 100. So 52.13 plus 13.15 plus 34.72, and it adds up to 100. Okay. So that makes me believe these answers are correct. That's percent composition. So carbon is 52%, 52.13. Hydrogen is 13.15% by mass, and oxygen is 34.72% composition, percent composition. Okay, one more example. P4O10. So P, we have 4 of these. Oxygen, we have 10. Okay, so phosphorus is 30.97. And oxygen is 16.00. So 4 times 30.97. You're going to get 123.88. That's grams per mole. 10 times 16 is 160 grams per mole. All right, so add those up. And 283.88. All right, so part of a whole, so 123.88 divided by 283.88 times 100, we're going to get 160.00 divided by 283.88 times 100. All right. All right, calculators, 123.88 divided by 283.88 times 100. We're going to get 43.64. Okay, and then the other one, 160.00 divided by 283.88 times 100, 56.36. Okay, so add those two together, you should get 100. And I get 100 exactly. So percent composition, 43.64% is the phosphorus. 56.36% is the oxygen. All right, so let's talk about what an empirical formula is. So write down this definition. All right, so the empirical formula in chemistry is the lowest whole number ratio of the atoms in the formula. So if we look at this first one, C4H10, whole number ratio. So right now, the ratio of carbon to hydrogen is 4 to 10. 4 carbons to 10 hydrogens. But is this the lowest whole number ratio? Well, if we look at 4 and 10, both of those are divisible by 2. So let's reduce this. So that's going to be 2 to 5. Now, can this be reduced anymore? And the answer is no, it can't. So the empirical formula for C4H10 is going to be C2H5. So that's called an empirical formula when you get the lowest whole number ratio. Okay, let's try another example. C3H6O12. So right now the ratio is 3 to 6 to 12. And each one of these is divisible by 3. So that's going to be 1 to 2 to 4. And this isn't reducible after that because we have 1 as one of our ratios. So this is going to be C1. We don't write the ones in formulas though. If it's a 1, we don't write that. We just let the symbol for the element indicate that there's one of those. H2O4. Okay, so that's the empirical formula for this molecular formula. So this one is called the molecular formula. This one is empirical. When you reduce it. Okay, one more example. H2SO4. So right now this is 2 to 1 to 4. All right, so we just said that if we have one of our ratios is 1, you can't reduce that anymore. So the empirical formula for this is going to be H2SO4. It's going to be the same thing. So the molecular formula is the same as the empirical formula for this particular molecule. All right, so empirical formula is really easy. It's just the lowest whole number ratio of atoms in a formula. All right, so how do we do that? Well, finding the empirical formula is like working backwards from percent composition. You're given a percentages, and then you must find the empirical formula and sometimes even the molecular formula or the true formula. So there's a rhyme that's going to help you remember the steps to work backwards. So write this down. Percent to mass, mass to moles, divide by smallest, and make them whole. All right, so let's work an example. So you have a problem here that says that a compound is found to contain 50.05% sulfur, 49.95% oxygen by weight. What is the empirical formula for this compound? All right, and then there's a second part that says the molecular weight for this compound is 128.14 grams per mole. What is the molecular formula? So we're going to be doing both the empirical and the molecular. So this is a two-part question. So let's work on the first part. All right, so we're trying to get the empirical formula from percentages. So our first step is percent to mass. Well, the way I like to work these is in columns. So we have sulfur and oxygen. So I'm going to put sulfur and oxygen here because we have those two elements. And it says that the percent is 50.05% and 49.95%. All right, so I'm just going to circle my givens here to show you where I'm getting these. And we're underlined what we're looking for, empirical formula. All right, so here I'm listing it out. Okay, I'm listing what we have. All right, so now I'm going to do the equation. The equation is the rhyme. So percent to mass. So on this first step, all you have to do is just take this percentage and rewrite it as grams. That's all you do. It's the same number, only we drop the percent off and we put grams. So percent to mass, because what we're doing here is we're assuming we have 100 grams. Since it's 100%, if you add those two up, you get 100%. We're assuming 100 grams. And then that's how we can change the percent to the grams. All right, so percent to mass, mass to moles. So we need to make each one of these converted into moles. So I'm going to go ahead and write it here and show you the long form, and then I'll show you the shortcut. So we take our given and put it over 1. Then we're going to go into those steps that we do for every conversion. We're going to go back to that. What unit is it that I want to get rid of? Well, it's grams. Where do I put that? On the bottom. So I'm going to have to force cancel that. So on the bottom, mass to moles. So we're trying to convert this to moles. So using your mole map, can you go from grams to moles? And the answer to that is yes. If you look at your mole map, you can go straight from grams to moles. So we look at the molar mass for sulfur. Well, if you look on your periodic table, sulfur is 32.07 grams per mole. Okay, so 1 mole of sulfur is 32.07 grams. Cancel what you can cancel. So we have moles here, and that's what we want. So all you have to do is the math now. So it's 50.05 divided by 32. Turn my calculator back on. All right. So 50.05 divided by 32.07. Oops. My calculator. I pressed the wrong button. All right. 50.05 divided by 32.07. That's going to give us, when we write out this whole thing, that's a big number. All right, so look at the shortcut. You're just taking the mass. You're just taking this mass and you're dividing it by 32.07 grams per mole. Okay, the grams cancels out and leaves you with moles. So I'm going to erase this so I can have more room. Okay, so let's do the same thing over here. This is going to, oxygen is 16.00 grams per mole. Okay, the grams cancels and just leaves you moles. Okay, so on sulfur, I calculated this, and this is going to be 1.5606 485 8123. Okay, and let's do this one now. So 49.95 divided by 16, we're going to get 3.121875. And this is moles. So percent to mass, mass to mole. All right, so we converted both of those to moles. The next step is divide by the smallest. So what you're going to do is look at these two values that you got, and you're going to decide which one is the smallest. Okay, so of course, the smallest one is going to be the 1.5. 606 4858123. Okay, so we're going to divide both of these by the smallest one. All right, so this is automatically going to be 1 because you're dividing it by itself. So we're going to take our 3.1285. We're going to divide that by the 1.5, 606 4858123. We're going to get 2.00037, etc. All right. The last step is make them whole. All right. So we take this number here, and this is 2.000, so that's practically 2. So we're going to make that a whole number. All right. So there you go. Make them whole. What you have here, let me scroll this down just a little bit. It's not going to scroll down. There you go. So what we have here is the empirical formula. So the empirical formula for this is SO2. So that's the empirical formula. All right, so that's the way you do that. It's very, very simple. All right, so here it says the molecular weight for this compound is 128.14 grams per mole. What is the molecular formula? Well, what we're going to have to do is for this one, we're going to have to calculate what is the molar mass of our empirical formula. So S, we have 1. O, we have 2 of those. Okay, so sulfur is 32.07. Oxygen is 16.00. All right, so it's 32.07 plus 16, and 16 is 32. We're going to add these together. So we get 64.07 grams per mole. So our empirical formula is 64.07 grams per mole. The true formula is 128.14. So if we look at this, we see that the 128.14 is a multiple of this number. So if I took 64.07 times 2, I'm going to get 128.14. So the molecular formula is twice the empirical formula. So if this is the empirical formula, and we know that the molar mass is twice the empirical mass, then all we have to do is double the number of atoms. Okay, so it's S2O4 is the molecular formula. All right, and that's it. That's the notes for this section. Let me just make sure. Empirical formula, molecular formula. All right, so yeah, that's it for these notes. We'll be doing all of these other examples in class. I'll do them as bell work so that you'll get to see more examples. And so we'll see you in class. Also, make sure that you subscribe and that you also click that bell so you know when I put up more videos and you can watch. Maybe I'll do example videos to help you out so you can watch more examples at home.